Hello and welcome to DevOps UK 2022. Thanks for joining our session on the shitposting AI, an ironic solution to fruitless online debate. I'm guessing all of you people have had problems with debating online and, well, just the general discourse online. And I hope we can present to you a solution for that today. So before we start, we want to introduce ourselves. First guy is going to be Thomas. Who are you?
Yeah, so hello everybody, my name is Thomas Endres. I studied computer sciences, and after my studies I joined the company TNG, and together with Martin we've been working for the last 10 years or so on innovative projects which involve bleeding edge technology. Once it was gesture control, then we went on to AR, VR, and lately we've been working more with AI. So Martin.
Microphone. Yeah, hi. So my name is Martin Förtsch, and I'm working for TNG since 16 years. Principal consultant, studied computer sciences, and this one guy here, this is Jonas.
Yeah, I'm Jonas. I'm a senior consultant. The slides are not up to date anymore. You can see I also have the cool titles as the other guys have. And I work in the innovation hacking team at TNG, and we do cool projects like this one that we're going to show today, but also stuff like real-time deepfakes, stereoscopic style transfer, autonomously flying drones. And it's not only the three of us that do that. We actually have an entire team behind us. And those are not working full-time on innovation hacking topics, but they're spending about 10% of their working time, which we call tech days, working on cool innovative projects like this one. And you might ask yourself, well, why does TNG Technology Consulting give people 10% of their time to work on, well, shitposting AIs? Well, the answer is the following. There's a couple of reasons. For one, we want to have them learn something new that's not quite out there yet. So obviously we don't have customers who want shitposting AIs, but nonetheless, this is a great opportunity to learn something about natural language processing. And what exactly that is, we're going to tell you in this talk today. Another thing is we want to motivate our employees, want to give them cool projects to work on as side projects next to their normal projects. And well, the third reason is basically just because we can, and because the stuff that we do is cool, and so cool that, well, media grabs attention of us. And here you can see, for example, Thomas being in an interview talking about deepfakes, and here you can see Thomas in an interview talking about deepfakes, and then here you can also see Thomas talking in an interview about deepfakes. So you can see we're going public with our stuff. We have quite a lot of media coverage, and with every bit of media coverage, there comes a little bit of a public reaction. And you can see we usually have like a flood of comments going on, and the constructiveness of them ranges from, well, very constructive to something like this. So this is a German comment, I'm gonna roughly translate that to you. Oh, the employees of TNG Consulting, that's not what we call it, by the way, they tape their cameras on their notebooks. You want to know how I know that? Because all of them do that. Maybe we did the Amish people wrong. So if you're wondering what this has to do with real-time deepfakes, I cannot tell you, we don't know. But this is something that we have to face every single day. And our typical reaction to this would be, well, just spam back at them. And we've been doing this for a couple of years now, and we noticed, well, we spend quite a lot of time there. And we thought maybe it might be worth it to have a look at how this social interaction on social media works. And that's basically how it looks like, what we came up with. So on the one hand, you can see here we have the typical shitposter who, well, will comment on stuff that we do. And on the other hand, we have the TNG GigaChat that's going to respond to it. And well, after that, the shitposter is just going to respond, and it's like an endless cycle. And everybody who's discussed online previously, he will know that, well, online discussion is time-intensive. Discussion never leads to anything. It's pretty fruitless. Nobody ever changes their mind online. And finally, well, it's very toxic and it's exhausting. And yet we somehow feel that discussing online and like putting our point out there is necessary. However, we thought to ourselves, maybe we could automate that. So we took inspiration from a previous project. It was called the Jonas Simulator. And the basic idea was we took an AI that, in this case, is GPT, and we trained it on a couple of blog posts of mine. And what we essentially ended up with was an AI that could speak using my voice and just basically ramble on about stuff like gradient descent and batch normalization for hours and hours and hours. And while I was on vacation, that was pretty handy because I could just have that thing take care of all my interns. So their basic idea now would be, well, what happens if we just take the Jonas Simulator, for example, and we just let it reply to the shitposter, and then we can do something useful, like work, for example. But then we took a step back and realized, well, it's not just a problem of ours. This is a global problem. It's like the other side is doing the exact same thing. They're wasting time as well. And if you look at the statistics, well, there's a statistic saying, well, every person in the world is spending around 155 minutes every day on social media. And if you think about it, like X% of that is going to be used for discussing opinions, and multiply that with the average, well, hourly wages, you can quickly see there's billions of dollars that are being wasted worldwide on discussing online. Doing very mundane stuff, very repetitive stuff. So we thought, when was the last time in history that we had something like this, where we had people doing the same thing over and over, and what was the solution to that? And it's a great opportunity to be speaking here in England today, because, well, that was the Industrial Revolution, right? You had stuff like, not sure what that thing is called, but previously to that, you had people doing repetitive tasks, sewing, doing like stuff, and now you have machines that do that. So we thought, okay, maybe we can have an industrial revolution for how we interact in social media. So the idea is to basically, well, we have a machine that does all the discussion for us. So basically, we have an AI that generates a comment and then generates a shitpost and then replies to that again. And doing this, we've basically taken the human completely out of the equation. We can still work, and even the shitposter can do something useful with his time and, for example, learn about clean code. And, well, the good thing is, if we create such an AI that represents all the opinions that we find online, every person will be happy with it. So you might look at this and think, well, how am I supposed to like identify with this floating AI brain kind of thing? And we thought, yeah, there might be some kind of uncanny valley involved here. So we kind of have to bring this back into a human form. And the obvious solution to that is robot heads. So take something something very nice like this, have that read the comments to you. You definitely feel like this robot thingy is representing you, and you don't feel the urge to discuss online anymore. And that's basically the plan that we have. For all of you who didn't get it so far, this is like a complete satire project. This is not like some business case that we're rolling out to customers. But nonetheless, we're going to talk about it. And we have a bunch of topics. So first, we're going to start with an introduction, just basically give you an idea what neural networks are, what natural language processing is, and how the project is structured in general. And then we're going to go over the 3 big steps. So first, generating social media comments, then generating human voices, and finally, building robot heads, such as this one right here, before putting it all together. So kicking things off, first off, we're going to have a look at, well, what is this all about, Martin?
Yeah, what is this all about? It's about NLP-powered robot discussions. So on the left side, we thought we need something like an artificial brain to generate those comments. And on the other hand, we will have something which speaks those comments out. Yeah, something like this wonderful robot head. Okay, it's not a robot, but we want to talk about the technology inside there later on. So NLP, natural language processing, what is this? Actually, on the one hand, linguistics, and on the other hand, computer science, and in the middle, it's NLP. So, where is it used nowadays? Yeah, most of you already use this stuff when having the smartphone, speaking a question, whatever you want, and text to speech, speech to text, Alexa, Google Home, and so on. Then we have automatic summarization, for example. Just take a document and generate a summary out of it. Yeah, or well, sentiment analysis in the stock market, maybe it's used, yeah, when the news coming out and if they're good or bad or whatever. So the question is, how does this stuff work? And this brings us back to school. So here you can see a human neuron, and maybe you can still remember that you typically, you need a stimulus, and if it exceeds a threshold, and action potential will be there. If the stimulus is not high enough, then there will be no action potential. And yeah, somebody tried to fit that into a mathematical model. And so, have a look here. x0, this is the input value, it's just a number. And this gets weighted with omega 0 in this case. And then it goes inside the artificial neuron. Inside the artificial neuron, you can add a bias. And then an activation function will calculate the final value. And we made this awesome animation here with 3 different input neurons and with different weights, omega 0.7, 1.4, and so on. So if it's more than 1, the information gets somehow more important, and vice versa. Yeah, okay, so now the question is, when we talk about text, how can we turn text into numbers so that we can use something like I just showed you, this mathematical model of an artificial neuron? So let's have a look to this example here, this sentence. Jonas Meyer is so nice. I'm not sure if this is right, but let's have a real look on this. So what you can do is tokenization. And the result after the tokenization will be just numbers. So you can see, for Jonas on the index 0, it's the number 4. Meyer gets the number 2. Is gets the number 1. And let's have a look to the word so. It occurs twice here, and it gets the same token ID. Yeah, and this is what tokenization is all about, turning text into numbers. Do we make a demo right here? Is it working?
Yeah.
Ah, awesome. Let's do a live demo, and hopefully it will not crash. So can you please hold my mic?
Yeah, sure.
With your remaining arm.
All right, so what you can see here is we have a tokenizer live in action, and Martin will now type a text. Well, for example, TNG Technology Consulting, and that's enough. Well, apparently not. Gives talks at Devox. Now you have to press create output. And then you will see, well, this sentence that we had will be split up into sub-words, actually. This is a sub-word tokenizer. So we have the token T, we have the token NG, Technology Consulting, blah, blah, blah. And all of that will be mapped to those numbers.
Yeah, right. And you can also see, for some words, it's not that accurate, but we don't care about that. So now we have the token IDs. What can we do with that? Let's talk about an example. Let's say we want to take the sentence, Jonas Meyer is so nice, and we want to have a look if this is spam. We want to make a spam detection on this sentence. How can we do that? Let's have a look for an example for a deep neural network here. We have the input layer, and you can see in the input layer that we have those numbers we just created, the token IDs. And the input layer in this case has 32 values, but they can be different, it's not a problem. And now those numbers go into the first layer of the deep neural network. And then all those artificial neurons could be connected with all the artificial neurons in the next layer, which would be a fully connected network. In the output layer now, we will have an example activation here for, let's assume 0.99, which would be 99%. This is for 99%. Jonas Meyer is so nice. What we can do right now, we can look at the ground truth. So with the labeled data we have. So we have labeled data, and there Jonas Meyer is so nice, has a spam label of 0. And with this, we could calculate losses. Jonas, isn't that easy?
Well, it's kind of easy, because no, it's not. Thomas.
Yeah, it's definitely not. So one thing you have to consider is that we might, so these tokens, they just have some arbitrary numbers. So if you have a look at this, so we have now on this line, we have all the words that are in the sentence. So if you have a closer look to some of the word pairs here, so Jonas and idiot, Martin. So they are close together. And
yeah, that fits perfectly.
Yeah,
right?
That makes sense. So this is pretty fine.
That's pretty fine, yeah.
Yeah, so close words should be close together. That's good. Then we have something like Jonas and human, but this is a huge distance here.
Makes sense.
I don't think so. So I think that could be better. And then we have something completely unrelated. So something like so and Jonas, and they don't really belong in any category.
They don't belong together, yeah, you're right.
So this is something we could improve on, so that words that are really close together also have somehow belong together and so have a distance which is not that great. And therefore, we introduce something, and this is the so-called token embedding. We're gonna LARP that away right now.
Oh, we make a LARP again.
Yeah, we have
never done this before.
Never, ever. All right. Our offline roleplay game will now consist of different animals, actually. So, Martin, I'm gonna give you a few animals, and then we're gonna use these animals, and you can put them on the screen at some point.
Okay.
And we're gonna start away, and I'll give you the first animal here, and you can just order them on this 2D screen somewhere. All right, first object.
Okay, a whale, yeah, okay, lives in the sea, so I just put it there. Okay.
Cool. Your next animal is going to be an elephant.
An elephant.
So how does that fit with the whale?
It's kind of an exotic animal for me. I'm living in Munich, so but at least it's living on land, so I would place it here. Okay.
All right. So let's have another animal then.
Yeah.
A penguin.
A penguin. Okay. Okay. Am I allowed to move the others again? Okay.
Sure.
Okay. So let's move the elephant a bit more here, because it's living more in the warm, and penguin more in the cold.
Okay, and then you have like one dimension for water, right? Okay,
yes.
That's interesting.
That's a really interesting choice.
Yeah, I see. Oh my God, a panda bear. That's tough. Okay, let's. Yeah, I don't.
How does that work? Okay, never mind.
Yeah,
let's just give you another animal.
Yeah.
And let's see. Oh, that's gonna be
just
interesting.
all those exotic animals here. For me, at least. For me.
Yeah. All right, shark down there with everything
one
that
more,
lives in the water.
right?
Yeah, let's give him one more. And let's see how it does.
Yeah.
Well,
that's kind of cute. Okay.
I would place it here. So yeah.
Okay, so as you can see, Martin,
yes,
you just place the objects where you think they belong. So objects that belong together are more down here, or up here. So things that are closely related to your own metric are also somewhere close together here. And it doesn't have to make sense. And obviously, in this case, it doesn't make sense. But to you, at least, it makes sense. And this is going to be fine, because this is the only important topic here, that we don't talk about completely different subjects which have a distance which is very close together. And this is something we'll have to remember for our tokenization and for every NLP algorithm that we have some kind of these token embeddings, and they are one pillar of the foundation of NLP. Okay, so let's go on to the second topic, and this is going to be generating social media comments. And so now we're talking about this part here. And we need some kind of brain. We need something that will really generate our social media comments. And we thought about something like, hey, why don't we take the OpenAI GPT or generative pre-trained transformer? And the comments on the website already tell us that it's pretty much the perfect solution for our problem, because it already states we can also imagine the application of these models for malicious purposes, including the following. And then there's a long list, and there's also automate the production of abusive or fake content to post on social media, automate the production of spam content. So we thought that's going to be perfect for us. So let's just use that. And here we have our model. It's called generative pre-trained transformer, as I already said. There are 3 words in that. The first one is generative. So it does not do any classification or segmentation like in a computer vision example. It generates text. The second word is pre-trained. And with pre-trained, we mean that it already comes with some knowledge. So it already knows a lot about the world. It was trained with half of the internet, basically. And with this knowledge, we can go on right away. And transformer is the model the kind of model that we are using here. We're going to talk about that a little bit later. It's obviously not Optimus Prime or something like that. All right, so let's have a look at GPT. I already told you that it is pre-trained, so we can just try to do some experiments with it. Now the demo is initialized, and we can type something in and see. It is also a network which is generating more text if you put in the first words. So we're just gonna start with Jonas. What are we starting with?
Yeah, we're starting with TNG Technology Consulting is. So let's have a closer look at what GPT thinks that our company does and is. And in a moment here, we're gonna see. Yeah.
A non-partisan research organization, okay.
That's kind of accurate.
That's kind of interesting, because it's just switching the attention to something completely different. Let's try out another one.
Yeah, because the good thing is you can run it multiple times, and it's just going to randomly probe something. Oh, Jesus.
Research on climate change. I didn't know that.
Not yet, right?
So, as you can see, it creates sentences which kind of make sense. They seem legit, even if they are not. Yeah. So
that even kind of makes sense.
Yeah, premier consulting firm. Okay, that makes sense. So if you happen to run it multiple times, there could be something useful which gets out of it. But it is at the moment not trained, and let's at first have a look at how this all works. What GPT does in the background is a so-called next word prediction. So what we are doing here is we are having an input vector. In this case, we have 1,024 tokens in total that we put into the network, and then we have an output vector of the same size. And then in the middle, our GPT is working. We're going to have a look at that in a little bit. But first of all, how do we now get these weird sentences which we just saw? So first of all, we're going to put in Jonas, or token for Jonas, and then we're going to get Maya. So this is our output. And then we're putting that back in. So now we have an input vector for Jonas Maya. And then we get out is, and we're going to go on like that, and always putting in the output as an input again. And this way we're gonna complete a sentence until we find an end of text token, and this will signal to us that there is nothing more that the network has to say, and then we're pretty fine with that.
Yeah. So right now we have GPT in there as just like this kind of black box blob. And we know that it's a transformer, not Optimus Prime, though, but let's have a look at what exactly that would look like. So if you have a look at GPT, you remember a neural network consists of multiple layers of neurons. And here we have multiple blocks of layers. So we have, in the case of GPT, 12 decoder blocks. And each of those decoder blocks, it consists of a masked self-attention layer and a feed-forward neural network. And the masked self-attention, or self-attention in general, is what gives transformers, well, on one hand, their strength and their powerfulness, and what makes them so special for NLP purposes. So we're going to have a deeper look at what exactly self-attention is. So in order to understand self-attention, you kind of have to understand how cheating on exams works. So the problem at hand is you're sitting there in the middle of the classroom, and you feel like you don't have all the information that you require somehow. So what you do is you take a little peek to the left, take a little peek to the right, you find out which information is relevant to what you want to achieve, and then you kind of combine everything onto your piece of paper. And that's exactly how a self-attention layer works. So take, for example, we have here this input sequence, and we have the token for he, and we have no idea what exactly that he refers to. So what the masked self-attention will do is have a look at the broader context. And now you can see, well, the sentence is, the shitposter is mad, full stop, he, blah, blah, blah. And so what the layer will do is it will peek at the words previous to he, for example, and figure out which of the words are important ones. And this is all done within the layer. So you can see, well, to understand what he means, shit, poster, and mad, and also he are keywords in here. So we're going to identify these important words, and then we're just going to bundle it in the output of our layers, so we get something like shit poster mad he. In reality, it's not going to look like this. It's going to be like all token embeddings. But you can see we're just going to bundle everything in there. And as you might imagine, just taking everything and bundling it in there is quite a mess, and that's why we have the feed-forward neural network part in here to basically figure out what exactly the masked self-attention just did. And if we put those two together, we have a decoder layer, and because the masked self-attention only looks backwards, we can do this beautiful next word prediction, because we always look at the previous words. So once we do this, well, we can run an input through, and the output will be only dependent on the words previous to that. Okay, so now we've understood how self-attention works, how decoder layers work. Now we're going to have a closer look at how GPT looks in detail. So we told you that we're going to take the text, we're going to convert it into tokens, and then we're going to convert the tokens into token embeddings. And as opposed to the demo that we had previously, we don't only have 2 dimensions, x and y, but now we have 768 dimensions in the case of GPT-2. And these token embeddings are going to be learned by the GPT network, just as Martin learned how to do his token embeddings on screen. And once we have these token embeddings, these go through the decoder stack as we had previously. And finally, we get, again, token embeddings out, which we are going to compute or token probabilities of. And in the case of GPT, we have 50,256 different tokens, so that's going to be a lot of data that we have in here. So now we have understood how GPT works and how GPT runs, and it does its next word prediction. But this is something that is just trained on the general internet. We want to do some shit posting now. So we have to train it on our custom data set. And how exactly is training done, Martin?
Yeah, let's have a look to that, training the GPT. So here in the input layer, we have the sentence, your deep fakes are shit. And yeah, so what we do now is we make a prediction. And if you take the word your, typically the next word prediction could be mom. And for the word deep, it could be fakes, and so on and so on. So the prediction could be something like, your mom fakes are nice. So how can we train the GPT right now? Yeah, we just have a look to our ground truth data again. And this looks like this. It should be your deepfakes are shit. And what we can do right now, we can have a look to all those differences between prediction and ground truth, which is very useful, yeah, to calculate a coast. And this brings us right now to the model we just wanted to use, so GPT-3 or GPT-2. And as GPT-3 needs several thousands of petaflops, we thought GPT-2 could be a better solution on that. And yeah, so we have here different sizes of the models. So you can see from 500 megabyte to 6 gigabytes, so different flavors available. So the larger the GPT-2 flavor is, yeah, the more decoders are in there. So, but there's still one question open. With which data do we train our...
Yep. So now that we have all the computing power and all the models that we really need, we also need to figure out, as a last point, where we get our data from. And there's a lot of opportunities here. So we can use all these different social media platforms here. And all of them have some good shit fakes. Shit posts, sorry. And but we figured out two of the best ones, and this was Twitter and Reddit, of course. Okay, and there are now some APIs with which you can really get all the posts from Reddit or Twitter that you want. So for Reddit, it's the Python Reddit API wrapper or PRO. And with PRO, you can just select all the subreddits that you want, and then just say from which time period you want your posts, and then you can just list all of them. And unfortunately, if you do exactly this, you'll get a lot of posts which are not that useful for our AI, because on the one hand, they are pretty shitty, but on the other hand, we don't always want to talk about porn. So that's a bit problematic. So that's why we chose some topics or subreddits that were worth it. And there is quite a few. So politics, change my view, unpopular opinion, shower thoughts, news, not the onion, political discussion, world news, and of course mechanical keyboards, because that's where we thought the most controversial discussions would be going on. And so with this we can now also have a look at Twitter. And with Twitter things are a bit different. So you can now create a query, then use some parameters to tweak that query, and then you can stream your data right in. So this is quite easy, and fortunately there is no such thing as with Reddit, so we can use most of the comments that we get. But on the other hand, we have the problem that there are some limits to the Twitter API. So you can just post a few requests every 15 minutes, a few hundred requests actually, and during a month a maximum of 500,000 tweets can be retrieved. But this is pretty fine for us, because 500,000 tweets should be enough for our network to learn. And with that, we are now getting data in a form that looks a bit like that. So there's a post, there's a reply to that post, there's a second reply to that post, then someone insulted the mom of the first one in a reply, and then the poster posted something back, and so on and so on. So this is like a tree structure, and our tree structure is not that suited for our input format. So what we are doing next is a technique which we call thread flattening. So basically we are just doing things like that. So we are just taking the post, then putting an end of comment token there, then taking the reply, and so on, and so on, and so on. So we are making this tree flat by using a depth-first search. And with that, we have now our input data in a format which we can really use and with which we can train. So talking about training, so this is going to be our next step. And there's also some difficulty involved here because we cannot just put the new training data into the buckets that are currently trained on. So that's why we are using a technique where we have 14 different buckets and we are scraping the internet continuously, obviously. But every day we just put our data into one bucket. So on Monday it's going to be bucket 0, then it's going to be bucket 1, and so on, and so on, and so on. And learning is just gonna take
P.
No. And learning is just gonna take place from the buckets which are not currently learned, which are not currently scraped to. So we can then learn on every bucket but the one we are currently scraping to. And with this, we have now trained our AI. We can then just upload it to our shitposting cloud, which could also be named Bitbucket. And with that, we can use our model that we get. And we now have a fully functional comments generator. So now we're going to do a live demo again. And it's currently loading. And then we can type something. Jonas is going to propose some topic.
A very controversial one, apparently. Yeah. So we're going to prompt the very controversial topic of COVID is a thing. And so you might know if you toss an opinion like this out there into the internet, definitely going to get interesting discussions. And that's what we're doing right now. So you can see, because we train basically our shitposting AI the entire time, it's also going to be discussing about current topics. Right now we have an offline version from last autumn. But today, the AI would also sidetrack and discuss about, for example, Ukraine and everything else that's going wrong or right in the world right now. So this is actually quite fun. You can just have it there and let it discuss for you. It will also generate things like fake Twitter links that are going to lead to nowhere, but nobody clicks those anyways ever, so that's all right. Yeah, and the fun thing is it's going to have learned from how discussions typically work on the internet. It's going to just make up some facts. It's just going to, well, we do have a couple of insults in here, but it's also going to be basically all the bad behavior that you would find on the internet.
There are even going to be fake studies in here.
Yeah, it's going to cite fake studies. It's going to sidetrack and start discussing about completely different things and just be insulting in general, which is exactly what we wanted, right? Like, this is now something that we could use to automate online discussions, so you don't have to do that anymore. Yeah. Okay. One more.
And this is so much fun that we are currently also thinking of.
Okay, Jesus Christ. Yeah, I think we're going to end it here and move on to the next topics. And we have 11 minutes remaining, so we're going to skip over this a little bit faster. So the next thing that we want to do is we want to read out the comments that we just generated. So to give you an overview again, this is the part where, well, the waves come out of the mouth in this case. And what we have to do essentially is turn text into audio. And this is a known problem. Every one of you who has like an iPhone or basically any kind of phone these days has a voice assistant or maybe one of those things at home. And we thought so too. We thought we had a look at what exactly does, for example, Google use for their home assistants, because it's quite neat. And it turns out they're using Tacotron. And Tacotron does not look like this. It actually looks a little bit more like this. And the way it works is, again, you have your input sequence, which is going to be a sequence of tokens. And that is going to be fed into an LSTM encoder and an LSTM decoder, which is going to predict a MEL spectrogram. And that basically is an image that tells you at which point in time do you have certain frequencies in the human voice. And in order to get that to be audio, you still need a so-called vocoder that's going to turn your spectrogram into a WAV file. And then finally, you get something that sounds a little bit like this, while I'm just noticing that we don't have audio, I think.
Oh.
No. OK, so just imagine you would have Arnold Schwarzenegger speaking very poorly. Ah, no, we actually have one here. OK, so yeah, that's long enough. OK, let's give this a try. OK.
The meaning of life is not simply to exist.
And you can hear, well, we're going to have
The
another
meaning
listen.
of life is not simply to exist.
You can hear, well, this kind of sounds like Arnold Schwarzenegger. It's a little bit rough around the edges, but it gets everything right. For example, the Austrian accents and everything that has to do with it. The problem is, if we have like a robot head discussion, we don't want Arnold Schwarzenegger to be the only person participating in it. So obviously, we want to have multiple voices. And one option would be to have simply multiple trained instances of Tachotron. But we thought we might go a little bit fancier and use something like Tachotron that does multiple voices. And that would look something like this. You can see you have your standard Tachotron up there. But one more thing is you have like a voice sample that you can feed into a so-called speaker encoder. The speaker encoder is going to encode how that voice sounds and basically have a bunch of numbers here that you can feed into the LSTM networks that's going to give you a sound file in different voice fonts. And this basically allows us to skip this step entirely here and just generate random numbers and generate new voices every single time. And the funny thing is, if you do that, you find a couple of implementations on the internet. If you run them, you'll find out something like this.
Control of the Senate. I never really understand how Republicans ever want to support anything the other side says they do. It wasn't really a Twitter update until I was in for the ride back from...
So we already told you we don't want to do porn all day, and we are also not drum and bass or dubstep DJs. So this is probably not something that we want to have. So we figured out, well, this implementation of the multi-speaker Tachotron is just not well suited to generate random numbers and read some shit posts. So we chose to use something else. And the solution to this is, well, Cocky AI, they have something pretty similar. In essence, it does exactly the same thing, but it just actually works. So now we have human voices that read the shit posts to us. Final step to do, basically, is to build the robot heads now. Martin.
Yeah, the robot heads. Yeah, let's have a look to that. At TNG, we are pretty experienced with robots. You can see the Now robot and imitating my movements here. This was a project from 2016, 15, I don't know.
2016, yeah.
2016. So what we did, the idea was we have this glass head here, and inside there is a Raspberry Pi to realize our Wi-Fi connection, and there is a loudspeaker attached as well. And additionally to the Raspberry Pi, we attached an Arduino, and to have an LED ring whenever this robot head thinks, the LED ring will show an animation, and we have also some blinking eyes. Yeah, so this was the idea, and as a chassis, we just used those glass heads you probably know from your where you can remain your headphones on, and additionally, to hold everything together, we printed a stand, a 3D printed a stand here, and of course we don't only have this one, we have several of those heads because we want to have a discussion. Yeah, that's clear. Yeah, okay, so this is the result in the end, and then you just place the glass head over this, and this is how it looks like when we assemble all this stuff. looks really kind of messy, but
It also
actually
is.
that's
also is.
hardware hacking at its finest. And to be honest, we expected this. This was our expectation, and the reality was this thing. Yeah. So this is the talking heads, and yeah. Putting it all together, Thomas?
Putting it all together. So last thing to do is take the brain, take the robot heads, and make that something which will work in combination. So unfortunately, NLP has huge hardware requirements, so you cannot just run them on a Raspberry Pi or something like that. That's why we are now talking about a solution involving client-server architecture. And this is how the final result looks like. We have something like a server, which would be a laptop or a workstation or something like that. And then we have all the heads which can talk to each other. And then we are going to have a socket connection between the server and the client. And at the beginning, the server will just start thinking, so it will run the GPT network. And it will also tell the robot head to think. So the lamps here, so the LEDs will be on, and it will just try to think. And then we're going to have the TTS, which will create a wave file. We're sending this wave file over to the robot, telling it to stop thinking and then start talking. And then it will talk. Once it's finished, it will tell the server that it's finished. The server will start thinking again with the next robot head, which is currently connected to it. And then the process will start over and over again. So this is basically what the complete thing looks like, and we would now have a full demo, but unfortunately our network is not available at the moment.
Yeah, so it broke you, basically. But you can just imagine having like one head rambling for the entire day. We also have videos of that on YouTube, so if you want to check that out, just do so. We've basically been just talking smack for an hour, so I think you've already kind of satisfied with this. And that is basically all that we have for you today. So to recap, we basically solved one of humanity's most pressing issues, which is online debate, obviously. And one thing that we didn't quite have a look at is the possibility to contribute to this discussion as a human, if you feel like you absolutely have to voice your opinion. So we had a look at GPT, and we kind of forgot about speech to text, so the ability to interact with the heads. I don't know, Thomas, if you just want to put that thing back together, just fire it up, and then you can see all the blinky things. And that's basically all we have for you today. This is us again, and if we have a couple of questions, we have 2 more minutes to ask and answer them. So we have a question over there. Thanks for your attention.
Jesus.
So AI is not 100% accuracy, right? So how often does it make good points?
Well, that's a good question. It sometimes accidentally makes good points, yeah. That's right. For example, when it tells you that there was a point in time to wear a mask, like that it actually sometimes it's just randomly sampling stuff from the internet. So there's going to be a few good points in there. Like most of that is actually just stupid stuff.
And did you release it on Twitter? Can we follow?
Sorry?
Did you release it on Twitter? Can we follow?
Not yet. That's a good point, though. So if you follow our socials, we're on Twitter and LinkedIn. And one thing that we're actually working on right now is building a website that has a continuous conversation going on that kind of looks like a Telegram channel. So that's going to be for all of you to enjoy at home. Stay tuned, follow our socials. And it's going to be ready in, well, when it's done, basically.
Yeah.
Thank you.
But it looks great. So this is going to be something that is going to discuss for years to come.
So it looks like you had so much fun doing that. That was amazing. My question is, there's an internet law called Godwin's law, which states that the longer a conversation goes on, the was it the probability of the conversation discussing or something being compared to Hitler or the Nazis reaching 1? So if you leave the chipbot running for long enough, does it start comparing people to Hitler? Here's my question.
That's a very good question. So actually, in our test, we could not confirm that. So it's probably due to the fact that we had a very good selection of subreddits, and also those subreddits are going to be very well moderated, and Twitter as well. So once conversations start to go that direction, I think mods would be kicking them, and that will be reflected in our training data and obviously our comment generator. But at the same time, it's not always going to be about, well, the horrible past of Germany, but it's also like you got some insults of moms in there, and you got some just insults in general. It's also going to be pretty racist from time to time. So
yeah, we had some pretty racist comments, but most of the not so nice comments were about Trump up until now. So
yeah. Thanks for the question. Very good question.
That was really good, really nice, really interesting. I've got one question. So on like certain, I'm guessing on like Reddit and stuff, there may be other bots and stuff, like doing replies and comments and threads and stuff like that. So how do you get over the fact that you might be training your data set on already like trained models?
Yeah, very good question. So we did, on one hand, we did some filtering for that. On the other hand, we don't care. So there's always going to be the Twitter bots that spam this comment like, this is a bot. You have to follow following rules. And basically every single comment that contains the word bot is going to be filtered out, or the sentence, this is a bot. So we take care of that by doing this, because we don't want to have like some moderator comments in there all the time. And then, well, obviously there's those alleged Russian hacker bots that are going to be going all around social media. But we think they are just an integral part of how the internet works today, so we decided to just leave them in our data set. Because also, most of the time, more often than not, there's not a single way that you could really distinguish between a bot posting shit
and we
a real
wanted to
person.
replicate what was out there. So
yeah, exactly.
Amazing, thank you.
Any more questions? Okay, not for now. But if you have any more questions throughout the day, feel free to just harass us. We're going to hang out somewhere in the venue down there all day long, basically. So feel free to talk to us. Feel free to hit us up on LinkedIn, for example, or Twitter. I think we got our Twitter handles, well, not on this slide, but literally every other slide. And without anything else to tell you, thanks for your attention. It's been a blast. It's great to be here in person again. And see you next DevOps 2023.
Thanks a lot.
Thank you.